Now, as we start part 2 of this section 10.3, we're going to look at what is called compound interest. Back in Math 1103, we did simple interest. Well, this is compound interest, and they give you this special formula. So you want to take a moment to copy this amount, or this formula, where the A is the future amount that you will get. Principal, P is the amount you are investing initially. And then there's parentheses, 1. R is the rate of interest that you're developing, 3%, 5%, 8%, 7.5%, whatever it is. Now, N is the number of times that the calculation will be compounded. Now, if it's annually, N is 1. That is once a year. If it's twice a year, this is going to be semi-annually. You would put a 2 there. If it was quarterly, you'd put a 4 there. If it were monthly, you would put a 12 there, 12 months. And if it's daily, you put 365 there. Now, the number of times it's compounded a year, we also use that up here as the N. But we now are going to times it by T. Now, T is the number of years. So, actually, you'll see it in action here, and then A is what we call the future amount, the amount that is accumulated for this time period. Okay, so here they're giving you a kind of a general thing. Find the value of $1,000 invested at this rate, which is 6% for 3 years. So let's set this up together, because the key is you have to set it up properly, then you just put it in your calculator. So P is going to be 1,000. Put a parenthesis there. Now 1 is easy. Now your rate is 6%. My Facebook page is coming up here. Pick that off. Now, they're saying they're going to compound it annually. So our N is just going to be 1 here. So we don't have to write that. And then it's going to be 1, which is our N again. And it's going to be for 3 years. So again, you can do it in steps, or I would do it this way. Since this is just the one, you're going to add this, 1.06. And then 1 times 3 is 3. You're going to use a caret, and then 3. And then once you can do that first, and then you times it by 1,000. But they're saying that calculators usually know how to do that. So if you put that in, 1,000, I'd put this in parentheses, and then I'd put the caret 3, and then you hit enter, and that should do it. All right, let's check it out here. And that's what we had. Now apparently they're doing this to the 3rd power, getting this, but you just get a value on your calculator. You leave that in there. You don't have to write that. And you're just going to times it by 1,000. So the future amount would be this much. Now, how much interest is here? Well, remember, you started with $1,000. So the interest after 3 years is going to be $191.02. You just subtract 1,000 from that. And they're showing you on the calculator here. Now, as we go into Part B of example 2, and you want to write this down, we have a new investment, and the formula was A equals our principal times 1 plus the rate over the number of compounded times per year, and then n times the number of years, t. So in this case, it's going to be 1,000 times 1 plus the rate is 6%. So I'll change that to 6%. Now, what is our period of compounding going to be? Well, they say it's quarterly. Now again, sometimes they often use 360 days instead of 365, but they'll tell you if it's daily or what and what to use. So here we're going to use the quarterly, which is 4. And this is for 3 years. So we have to use our n, our period of compounding, which is 4, times 3. So this is going to end up being a 12. So what I would do is I would put 0.06 divided by 4, add 1 to it. Then I would do caret 12, get a value, and then multiply it by 1,000. So let's check it out here. So there's what we had. So when they did the division here and added 1 to it, they got this, caret 12. But again, I think you could put this in your calculator, 1,000 parentheses, caret 12, and it should give you this answer. Now, notice this is just a little bit higher interest. You're getting a little bit more because we're compounding it more often instead of once a year. Okay. All right, now we're going to do the very same thing, but this time our compounded period is going to be 12 times a year. So it'll be 1,000. We could write the formula again, but we know it. 1 plus 6%. Now our compounding period is 12. Parentheses, but here, note, you have to go 12 times the 3 years, which will be 36. So you're going to do this division, add 1 to it, get a value, caret 36, and then times 1,000. And you need to be careful and know how to do it so that when you do it, you actually get the correct answer. Because just hitting the wrong key or putting something incorrect, of course, garbage in, garbage out. So this is 36. 12 goes into there this many times. You add 1 to it, you get this. Now they're showing that this is now just a little bit larger than what we had before because you're compounding it a little bit more often, and this is $1 or $2 more than what we had before. Now again, you want to write these examples up so you see what the protocol, the strategy is for doing them, and of course you want to check it on your calculator. All right, now another major kind of interest that we run into in banks is that we say it's compounded continuously. Compounded continuously. So write this down. And they're introducing one of the numbers here, which is an irrational number, and it's called E. Now, E is defined as an irrational number. Notice it doesn't repeat, but it continues. So they usually round it off here to 3 decimal places, which is like this. But in your calculator, there is an E value. So on your calculator, you want to find that E value, because that's what you'll use in the calculation. Now, this E, interestingly, is a little background. This will probably be one of your quiz questions. Is named after a very famous mathematician. Now, you would think you'd pronounce that Euler, but in the German, it's Euler. It's like oil, O-I-L-E-R, Euler. Even though, so I had made that mistake myself, so I just pass it on so you'll be a smart person here. So Euler is the famous mathematician that the letter E, this concept, is named after. We use the first letter of his name in lowercase as E. All right, so let's see how that works now. And you should write this value down. Now, the formula for continuously compounded interest is this. So you want to write this in your notes as well. So P we know, that's the principal. E is this mathematical symbol that has the value we did on the other page. But now, for our exponent, we're going to use the rate times the time. Now, since it's continuous, we don't have any n here. The E takes care of the n part. That is the compounded period. So this is just another formula you're going to need to be familiar with and have in your notes. This might be a quiz question. All right, let's go on to the question they're going to ask us here. Find this value, and again, they're using that same model again and again, just to note the slight differences that occur. So here we have P, E, RT. So our principal is 1,000. E we're going to put in our calculator. Now, in some calculators, you have to put the caret. In other calculators, you don't need to put the caret, so you're going to have to check that out. But our rate here is going to be 0.06, and our time is going to be 3 years. So this is what you put in your calculator. And again, you would do the E perhaps first. If it needed a caret, you'd do that. If not, just type that in. Sometimes you have to put a closed parenthesis, and then you go times 1,000. And they're showing you on a TI-84 here. Okay. And they're saying you could put it all in as one shot. And again, just a little bit higher interest. So you've got for 1 year, for quarterly, for monthly, and now you have continuous interest. So it's not a lot more money, but a little bit more. Okay, now we have some practice problems, and since we are only 10 minutes into this, and we're going to have this in 2 parts, we'd like you to actually do this. So let's pause, copy it down, and I'll work with you. So as we look at this, we've set up a little T-chart here. And if x is a 0, 3 to the 0 power is 1. 2 times 1 is 2. And if x is a 1 here, 3 to the first power is 3. 2 times 3 is 6. Now if x is 2, 3 to the second is 9. 2 times 9 is 18. So if we're going to quickly make a little graph here, and just to sketch it in a little bit here, 0, 2, so we got a 2 there, a 1, and then we're going to have a 6, is going to be about there, and then a 2, this is going to be an 18 way up there, and on this side it just goes down like so, but on this side it looks like this. I'm not doing that too well, but you get an idea. And you want to know how to do the calculation of this. Now our asymptote is still the x-axis, our horizontal asymptote. This line gets closer as we have negative values that are fractions. They get closer and closer to 0, but never reach it. Okay, let's go on to number 2 now. And setting it up, we're going to look for decay. Now this is a negative, so we didn't do any like that. So let's see what this will look like. Make our little t-chart here first, and I'll get back. So looking at this one now, in number 2, this is 0.5. We can think of that as 1/2. And this is 2 to the negative x now. So when we put negative 0, anything to the 0 power is 1. So negative 0, anything to the 0 power is 1. So this is just 1/2 of 1 is going to be 1/2. Now, if this is a 1 here, you may recall that we had said 2 to the negative 1 was actually 1/2 from an earlier lesson. And 1/2 times 1/2 is going to be 1/4. And if this were a negative 2 here, 2 to the negative 2, we said was 1/4. So 1/4 times 1/2 is 1/8. And then if we put a negative 1 there, now a negative 1 times a negative gives you a positive 1. So this becomes 2 to the first, and 1/2 of 2 to the first is 1. So let's graph that now and see what we get. So sketching this in, when I plotted these points over here, my curve looks like this. Now your x-axis is still your horizontal asymptote, but instead of it looking like we had earlier when positive values, let me draw a line in red here to show you what we had earlier. We had things that looked like this, exponentially. Here it's starting high on the left and going down. These are your negative exponents up here, giving you this kind of curve. It's actually the opposite to what we would have on the other side. Okay. Now, to go on with number 3, we did some like this. And once again, the formula is A equals P 1 plus R over N to the NT power. And you could work these out. I'm not going to do them all because I see now we're running over a little bit. And is there another page to this? Alright, there's the first graph, there's the second graph, and there are your compounded interest items. Okay. Alright, well, not too bad.